Welcome back to RS Academy. This is Ravi Shankar, Chemistry. In this session, let's have a talk regarding to classification of acid, especially based on concentration, based on composition, based on strength. Get ready, students. Putting along with me. Based on based on based on strength, based on strength. Acids are classified into different types or based on different points, based on source, based on basicity, like that. So in this session, we are going to discuss based on strength. Based on strength, acids are classified into two types based on strength. These are strong acids, strong acids, strong acids, and weak acids. Weak acids, strong acids, and weak acids. Acids are classified into two types based on strength: strong acids and weak acids. What is meant by strong acids? Strong acids means those acids produce more number of H plus ion or hydronium ion in water by complete ionization. Make a note of it. Acids which produce more number of H plus ions or hydronium ions in water on complete ionization. Complete ionization is called strong acid. Strong acid means those acids are ready to produce more number of hydronium ions when they dropped in water. On complete ionization, completely dissociated, completely broke down. So these are called strong acids. Example. So let us take general formula first of all. Let us assume this is symbolic representation of strong acid. When the strong acid is dropped in water, it split up into H plus ion or hydronium ion along with negative ion. It's a completely ionization. So it's a irreversible reaction. So this acid completely ionized in water and produce charged particles, but these charged ions or particles won't come back. They won't combine and give molecule back. So that means completely ionized, completely dissociated, completely broken down. So these kind of acids are called strong acids. Strong acid means produce more number of hydronium ions or hydrogen ions in water on complete ionization, considered as strong acids. Example: nitric acid, hydrochloric acid, sulfuric acid, generally considered as strong acids. Is it clear to you, my dears? Right, very good. Strong acids. Now let us have a talk regarding to weak acids. Weak acid means those acids which are ready to produce very less number of H plus ions or hydronium ions in water on incomplete ionization, incomplete or partial, incomplete or partial ionization, incomplete or partial ionization, incomplete or partial ionization, not complete ionization. That means they may have chance to combine charged particles and give back molecule. Let me take generalized formula. Weak acid, let us assume is a weak acid, dropped in water, it's produced H plus ion along with negative ion. You must have know that. Splitting of acids. I said so many times. So please go to the previous videos. Then you will get clear picture how the acids are split into the respective ions. Right, ma? Right. Next one. Here, when the molecule dropped in water split into ions, and again if you add one more molecule to that, the first molecule which is splitted into ions are combined and give back molecule. That means it's a chance combine the ions and give the molecule back. So that's why there is no availability of more number of hydronium ions, or there is no availability of more number of H plus ions. Listen to me, it's a very important one. For example, let us assume I drop two molecules of acid in water. Let us assume among two molecules, one molecule split into ions and second molecule also going to split into ions. The first molecule which is splitted already, it's combined with the ions splitted by the first molecule or given by the first molecule, combined and give back the molecule. So that's why one by one splitting into ions and one by one ions are giving back the molecule. So that's why there is no availability of more number of hydronium ions. So this kind of ionization is called partial ionization or incomplete ionization. The last, those acids are ready to produce less number of H plus ions or less number of hydronium ions on incomplete ionization, not complete, or partial ionization. These kind of acids are considered as weak acids. Weak acids. Example, all organic acids are weak acid. Formic acid, acetic acid, all organic acid. One more example I would like to give here, that is carbonic acid. Carbonic acid is inorganic acid, but it's a weak acid. Is it clear to you, my dear? So what is a weak acid? What is a strong acid? So acids can be classified into two types based on the strength: strong acids and weak acid. Strong acid means those acids are produced more number of H plus ions or more number of hydronium ions on complete ionization. Example, when the acids are dropped in water, they split it completely dissociated and split into ions. These kind of acids are called strong acid. Example, hydrochloric acid, nitric acid, sulfuric acid. Generally, inorganic acids are strong acids. Next one, weak acid. Those acids are ready to produce very less number of H plus ions or hydronium ions in water on partial ionization or incomplete ionization. Example, formic acid, acetic acid, and carbonic acid, which is inorganic acid. Okay, right here it's a reversible reaction. That means the molecules are going to split into ions and ions are combined and give back molecule. So simultaneously forward and backward reaction taking place. So that's why there is no availability of more number of H plus ions or more number of hydronium ions. So that's why this is considered as weak acid. Is it clear to you what is meant by weak and strong acids? Okay, right. Now let us have a talk regarding to experiment to distinguish which one is a weak acid or which one is a strong acid. Get ready. Right. So take two beakers, equal length and volume. Right. Let it be A. let it be B. Insert two electrodes made up of graphite. Made up of graphite. Right. Now, form a circuit as shown in the figure. Form a circuit like this. Right. The positively terminal, the negatively, the positively charged electrode, negatively charged electrode. Right. Now, in this beaker A, add 3 ml of aqueous solution of sulfuric acid. Aqueous solution of sulfuric acid. In this one, add 3 ml of aqueous solution of formic acid. Formic acid. This is aqueous solution of hydrochloric acid, sorry, sulfuric acid. This is aqueous solution of formic acid. Now, switch on the circuit. Now, switch on the circuit. Is an incomplete, is an open circuit. Let us close the circuit. Switch on the circuit. If you switch on the circuit, you must have seen that bulb start glowing brightly in case of beaker A. In case of beaker B, you must have seen that bulb glows dimly. What is the reason behind that? In case of A, we added sulfuric acid. Sulfuric acid being a strong acid, it's ready to produce more number of ions on complete ionization. Due to availability of more number of ions, the conductivity of water increases, the conductivity of aqueous solution increases, and bulb start glow brightly. In case of beaker B, we have taken aqueous solution of formic acid. The formic acid is a weak acid. Being a weak acid, it produces very less number of ions. That means molecules are split into ions and ions are combined and give back molecules. So due to the reversible reactions, there is no availability of more number of ions. If the number of ions increases in the solution, the conductivity of the solution increases. Here number of ions are increases, so that's why conductivity of the solution increases, bulb glows brightly. In this case, there is no availability of more number of ions. Due to that, the conductivity of the solution decreases when compared to this. Then bulbs start glow dimly. So based on this experiment, we came to know that which one is a strong acid and which one is a weak acid. Is it clear to you, my dears? Right. Very good. Make a note of it. Next one. So classification of acids based on concentration. Classification of acid based on concentration. Based on concentration, the acids are classified into two types: concentrated acids concentrated acids, concentrated acids, concentrated acids, diluted acids, diluted acids, concentrated acids and diluted acids. Concentrated acids. The concentrated acids consist of acid and water, but acid is large quantity, more amount of a large quantity of acid and less quantity of water, less percent of water and more percent of acid. This kind of acidic solution is called concentrated acid. So concentrated acid consists of very less amount of water. So 100% of concentration acid not existed, because of if it is 100%, it's never act as a acid. Because of being acid, it must produce hydronium ions in water. Without water, it never and never act as acid. So there is no 100% of concentration concentrated acid, because of it should not be considered as acid. So in case of concentrated acid, more amount of acid present and less amount of water is present. In case of diluted, acid is present and water also present. And here, so acid is a less amount and water is a more. That means what I mean to say, diluted acids consist of more number of water and less amount of water and less amount of acid. In case of concentrated acids, so concentrated acid consists of more amount of acid and less amount of water. Is it clear to you? Right. Next one. Right. So concentrated acids are converted into diluted acids by adding acid to water. Listen to me. Concentrated acids, very important. Concentrated acids. Let me write here. Concentrated acids are converted to diluted acids by adding acids to water. Acid to water. This is a very, very important method. Based on this, you will get the question. So while diluting acids, you should follow this order. So acids must be added to water. Acids must be added to water. Because of the dilution of strong acids and strong bases are exothermic in nature. During dilution, the large amount of heat is generated. So that's why if you add acid to water, the evolved heat energy is equally distributed among all the water molecules. So that's why there is any set of violent reaction. So that's why acid always added to water during the dilution. Please keep that point in your mind. So these are the classification of acids based on concentration, based on strength. Is it clear to you, my dear? Right. Thank you. Keep on learning. Have a nice day. Take care.